This last lesson in Unit 7 is going to cover systems of linear inequalities. And it will probably be beneficial for us to do a quick review of what it is to graph a linear inequality, because all graphing a system of linear inequalities is just graphing more than one of them on a single coordinate plane. So as a quick review, if you were graphing a linear inequality, we looked at like 3 different variations. There's a vertical, horizontal, and then has a slope, not 0. So just as a quick review, if you had to say the line x is greater than or equal to -2, the greater than means that you're going to shade in x values that are bigger than, or equal to means that it can also be equal to -2. So what it means is that the -2 is included, and then the -2 tells us where that line is. And so what we would do is we would go over to x is equal to -2, and we would use a solid line. Sorry, that's a terrible solid line, but there we go. And where would we find x coordinates that were greater than -2? I have a cat running around. I don't know what his deal is. It's not the one that's usually causing a ruckus. It's a different one. What is... Okay. Anyway, where would we find the x values that are greater than or equal to -2? They would be over here to the right. And so we would shade to the right, and that would be the graph of the linear inequality. If you had an inequality like y is less than 3, now we're looking at a horizontal line because the slope is 0, and we'd go up to the 3, but y is equal to 3 is not included. And so to indicate that the boundary line is not included, we use a dashed line. And where would we find the y values that are less than? They would be down below, and so we would shade it in like so. And then the last type of linear inequality that we might see would be, we'll do something like, oh, that's not an inequality if I make it equal. Let's do greater than -1/2 x plus 3. Okay, and so we would graph the line y equals -1/2 x plus 3. So that has a y-intercept of 3, and then the slope is going to send us a down 1 and right 2. And because it is greater than and not actually equal to, when we go to put the line in, we're going to use a dashed line. And then there are 2 ways you can figure out which side to shade. One is to pick a test point and see which side is the true side and which side is the false side. And so the way that would work is we'd probably pick the origin, not because there's anything magical with the origin, just like it's easy because it's 0, 0. And so we'd go and plug in y is equal to 0, and we'd plug in x is equal to 0. And that simplifies to 0 is greater than or equal to 3, which is false. 0 is not greater than or equal to 3, which means that this side over here is the false side, which means this side must be the true side, and then we always shade the true side. The other way you can reason that out is you can look at the greater than and then look at the placement of the line and say, all right, well, where do we find y values that are greater? Well, that would be going upward on the y-axis, and so that could also tell you which side to shade. So how does this relate to systems of linear inequalities? Really simple. You would just graph more than one of them at a time. So let's take a look at we'll do this one here. Okay, so my system is going to be y is less than or equal to x plus 2, and y is greater than -1/2 x plus 5. Now you'll notice when I wrote them down that I wrote them down in 2 different colors, and that's because using colors for these problems can be really, really helpful. So let's see what we need to do here. So I'm going to pick the green, and I'm going to go ahead and graph this first inequality, which has a y-intercept of 2 and a slope of 1. So remember that the number in front of the x there is a 1. And so I would go up 1 over 1. And before I connect them, I want to note what kind of a symbol I have there. So I have less than or equal to, which means that I will use a solid line. And this is a less than, and so the fastest way to graph this is to look at your line and say, okay, well, where on this would we find y coordinates that are less than? So I like to look at the y-intercept. So you look at the y-intercept and then you'd go less than, which is going to put you down here, which puts you on this side of the line. So when you shade this in, make sure that you are shading the entire region. For some reason, sometimes my students, they'll draw their lines really short. Like they'll just kind of put the line like right in here, which is fine if all you're doing is graphing a line. But if you need to graph the inequality and you need to do the shading, then it becomes really awkward when you have this like tiny little line. So draw the line all the way across the available space that you have so that you're seeing the whole thing. Okay, now I'm going to switch the colors and do the other one. So the next one has a y-intercept of 5, 1, 2, 3, 4, 5, and a slope of negative 1/2. So I'm going to go down 1 and right 2. And I do want to pause, okay, and make sure that I do the right type of line. Now, sometimes we can go on autopilot. My students will do this all the time. So they'll go and they'll draw a solid line just by default, just because we do that all the time. So if you're working in a pencil, you can just go back and just like do this little number and make it a dash line after the fact. If you're working in pen, sometimes students will do, they'll do like this number in a pen. They'll just do, okay, and they'll try to make it look dash. Obviously, the best thing that you can do is erase it and just redo it. Or sometimes students will write me a little note and say, "Miss Taylor, I know this was supposed to be dash, and I messed up." And I'll, as a teacher, I'll honor that. Like it just because I know that sometimes we just go on autopilot, but we do want to recognize that that is going to be a dashed line there. And this one is greater than. And so I would look above. So you can find the y-intercept and look above. That's where your y's are greater. Now, here's where students sometimes have a hard time. You kind of have to ignore the fact that the green line and the green shaded region are already there. Like just, you totally disregard them when you're doing your shading. So when I go to shade for the red line, I'm going to shade this side of the red line. So I'm going to shade here, but then I'm going to cross over into that green region. As long as I don't cross the red line that I have there, I'm doing okay. So we're just going to shade that in. Okay. And then the solution is this region right here. So I always require my students have to clearly show the region of overlap. And they can do that by doing it in different colors. You can do it by shading in different directions. I can show you what that looks like in another problem. But it's got to be very clear. When I taught dual enrollment, I would actually make my students kind of right in that section because you really want it to be clear that you understand that the solution to the system is the values of the variables that make all of the equations, or in this case, inequalities in the system, true. So just like with a system of equations that you're solving by graphing, maybe I don't want to put it quite there, but okay, the solution would be the point of intersection. It's exactly the same concept where you're looking for the intersection, or in this case, we might use the word overlap instead. But the green represents all of the points that work for the green inequality. The red represents all of the points that work for the red inequality. Therefore, the solution set, by definition, is the points that make both inequalities true, and that's going to be your region of overlap over there. Now, a couple things I do want to point out before we move on from this. Sometimes students do some really dodgy things, particularly if they don't know what they're doing. They will try this kind of move. They'll shade, I don't want to mess it up. Let me do a copy duplicate page in ink. Okay, so got this. Okay, so what they'll do is they'll shade like this. Okay. You guys get the idea, like what I'm doing here. Okay. So maybe they know which side to shade on, but they really aren't very confident about their graph, and they shade in such a way that they obliterate the line. Okay, like the line is gone, and I cannot see where the line was supposed to be or where their points were intended to be. So what I always tell my students, like, here's what I need to see. I need to see at least 2 points on your line. So don't shade so enthusiastically that I can't actually see where your line is. So the safest way is to make sure that your 2 points that you use to graph the line are still clear. I need to be able to see whether your line is dashed or solid. Okay, so you can't do your green shading so intensely or get your red shading so close to that I can't see that it's dashed anymore. I need to see that you're shading on the correct side, and I need to distinctly see the region of overlap. Now, some students will only shade the region of overlap. So theirs might look something like this. Oh, where? Okay, I think I'm on the right side. So they might do something like this. So they actually won't show the shading for the other two regions. Okay, they just won't do it, and they'll only shade that region. And some students can do that, and some students kind of struggle with it. Okay, so I think that is pretty comprehensive there. We still have that lovely mess and that. Okay, do a quick other example. I'm just gonna make this one off the top of my head. Y is less than 2x minus 5, and y is less than, oh, I don't know, what do we want to do? Negative 1/3 x plus 1. Okay. So another way you can do this, and I wanted to try to vary this up because sometimes as a teacher, we want to keep reviewing like, oh, is it solid? Is it dash? And so what we might inadvertently do is we make all of our problems so that the lines are either like, there's always one dash line and one solid line. And that's not because that's how it has to be. It's just because we're trying to review more stuff and just keep covering the concepts in every problem. So I do want you to see one that's both just less than, there's no equal to, and they're both less than. So you don't have like a less than. It's not like you have to have a less than or a greater than. So let's see. So this first one is 2x minus 5. Ugh. So I'm going to go down 1, 2, 3, 4, 5. And then for my slope, I'm going to go up 2 and right 1. And that is going to be a dashed line. And it says less than. So I'm just going to show you a different way of shading if you don't have access to things that have different colors. So one of the ways that you can shade is just by doing these nice lines. You can try to make them perpendicular to the line in question, but you don't have to. And then I'm going to do the other line in the same coloring. So I have a y-intercept of 1, and then I'm going to count down 1 and right 3. And like I said before, you do want to make sure that your points are really clear. This is also a dashed line. You can see why this is actually illustrating why we don't like to do it with the same color. It just makes it harder to see. And this one is also less than, so we're going to be shading underneath it. But when I go to do this one, I'm going to do my shading in a different direction. And then what happens is you end up with the section that looks kind of plaid. And so that's a really clean, straightforward way of illustrating where the region of overlap is without necessarily using different colors. So I like to use different colors. I think it helps. And I'm the kind of person that likes to write with a lot of different colors anyway. So I'm going to do one more example just to do, we'll do a system with 3. So we're going to do y, that's a y. Y is less than 2. X is greater than or equal to negative 1. And y is greater than x minus 2. So I'll do the first one in green. Y is less than 2. So we're going to look at the y-axis. We're going to go up to 2. And then pretty much we want anything less than 2. So we're going to draw a horizontal line, dashed, going across here, and then shade underneath it. So there's that. And you want to, because you don't really know what the rest of this is going to look like, don't go too crazy with your shading at first. You can always darken it in later if you want to. And then the second one, x is greater than or equal to -1. So we're going to go over on our x-axis to the -1. And that is a solid line. And we're going to go greater. So on the x-axis, that would be in this direction. And notice how I'm trying to be careful not to obliterate my green line with a red line. You just want to be careful of that. And then my last one is y is greater than x minus 2. So the y-intercept is -2. And the slope right here is a 1. So I'm going to go up 1 over 1. Make sure that, and again, you don't want to shade too darkly, because if I shade too darkly, I don't stand a chance at being able to see where this purple line is going to be. This is also going to be a dashed line. And we're shading greater than, which means we're going to go above. And so I'm going to shade, okay. And then if you look closely, the solution is going to be where all 3 of them overlap. And so here I've got, just so we can see, here you have just red. Here you have red and green. Here you have red and purple. Here you have just purple. Here you have red and purple, and right in there is all 3. And so what I would do in a case like this is I would actually recolor over it, just because it's not super obvious where that region of overlap is. And if you're doing this for a grade, for a teacher or something, you want to make sure that you're conveying what you know clearly. There's some pretty cool applications for this. I do one in my algebra classes, just a fairly simple one. I do You Can Learn Math University. So somewhere I have another video on my YouTube channel where you can find that problem. But you can use Math University. You can do, not use math. Well, hopefully you can use it too. But we have GPA and GPA 1, 2, 3, 4. 1, 2, 3, 4, and oh, that was not well done. Let's try that again. 1, 2, 3, 4, and 3, 4. At the school that I work at, the GPA is like I don't think anybody has a 5, because you would have to take all classes that went that high, but honors classes and stuff and AP classes are weighted, so you can go above the 4. And then over here we have the SAT score, and that's going to range from 200, 400, 600, and 2, 3, 4, 800. Okay. And I forget what the numbers are that I use in my little word problem example, but I say something like, You Can Learn Math University will accept students that have a GPA of at least 2.5. So all those GPAs are good, and a math SAT score of at least 500. And then basically say, okay, so what do each of these regions mean? So you get into the university, you need to have a math score of at least 500 and GPA of 2.5. So and it's a great example that inequalities are actually a lot more common than equations are, and because it's not just one GPA and SAT score combination that will get you into this university or qualify you for that university. It's actually a lot of different combinations. And so that's what's represented by the shaded region. These are all the students that meet both of the qualifications. Technically, you can't get above the 800 on the math SAT, but I did the graph in a hurry. Okay. So these are the people that it works for, that meet both. These folks meet the SAT qualification, but not the GPA qualification. So they do well on the test. They've got some stuff going on the test, but they don't have the grades to back it up. These are students who have the qualifying GPA, but not the qualifying SAT score. So there's a lot of students like that work really hard and they get good grades in school, but they go to sit down and take a test like the SAT and it just doesn't come together. And then these are students that do not meet either of the qualifications. And, we usually have a discussion in class about, if you're right here, should you still apply? And most students will say, yes, you should still apply because it depends on what you're applying. Like the college applications is a messy process. And so if you've got like an artistic or music or sports ability, something that can make you stand out in the crowd, it might be enough to kind of tip that in your favor if that's a college or university that you really want to go to. So that completes the lesson on systems of inequalities. As always, I will give you guys a couple of practice problems that you can work with and just reinforce the skills from this lesson. Okay, just 4 problems because these are a little bit more involved. So first one is 4. And so that'll be fun. Y and x are both greater than or equal to -1, and x is less than 1 or equal to 1, and y is less than or equal to 2. I'm sorry if I say one of them wrong. Number 2, y is greater than or equal to -2x plus 2, x is less than or equal to 2, and y is less than or equal to 1. Number 3, y is less than or equal to 1/3 x minus 1, and y is greater than 1/3 x minus 4. And number 4, 2x plus y is less than 3, and x plus 3y is less than or equal to 4. So pause the video, check these problems out, do them out on your own, and unpause the video to check your work. Okay. As always, pause the videos and make sure that you're checking your work. What I did on mine, and you'll see it in this one, is I actually did not do all the shading. I opted only to shade the final answer. That is for clarity. It's not because it's more right. I just thought that it would be easier for you to see it if I didn't have all the shading in there. So the first one, you should have a horizontal line. Y is right here. Y is greater than or equal to -1, and so you're going to shade above the red line. X is greater than or equal to -1 means you're shading to the right of the green line. X is less than or equal to 1 means you're shading to the left of the blue line, and Y is less than or equal to 2 means you're shading underneath the purple line. And so when you look at all of those regions put together, it ends up being that enclosed region in the box there. Next one, this one we have the red line, which is y is greater than or equal to -2x plus 2. And so again, you want to make sure that you can see the points clearly on those lines. Like how did you get the line where it is? And we want to shade above that line, which is going to be in this direction over here. X is less than or equal to 2. That's this vertical line right here. And then less than means that we're shading to the left. So that brings us like to this region. And then Y is less than or equal to 1 caps it right there. And so your final region should be that interior triangle there. And you should be able to see that all 3 lines are clearly graphed. Nothing should be shaded over so that you can't see where the green line or the blue line or the line is. Next one, this one we have y is less than or equal to 1/3 x minus 1. So down 1 and then we go up 1/3. That's a solid line and we're shading underneath it. And then the next one is y is greater than 1/3 x minus 4. And so there's your line there. That's a dashed line and you're shading above it. So what you have there are 2 parallel lines and you'll notice that they have the same slope and you're shading underneath one and above the other one. And so sometimes that will result in no solution, like if you were shading up here and down here, but it's not. There is a region of overlap, and where they overlap is like that strip in between the 2 lines. And the last one, this one requires you to do a little bit of algebra. And so on this top equation, I subtracted 2x from both sides to get y is less than -2x plus 3. And that's this line right here, Here's the plus 3, negative 2x, dash line, shading underneath. And then for the second one, I subtracted x from both sides and then divided everything by 3. And so that left me with y is less than or equal to negative 1/3 x plus 4. And so that's this line right here. That was a solid line, and we're shading underneath it. So because of both of them end up being less thans, you're going to shade underneath both, and so the region that's underneath both would be that purple region there. So hopefully this lesson helped. It hopefully reviewed the graphing of the linear inequalities, and we have an idea of a system and what a system is, and then this gives you an idea of like an application for it. So when would you be looking at this set of points? And just in case anybody's wondering, the only way we really do these is by graphing them. So we don't, and I have an extra slide here. Yay. So anyway, the only way you would do this is really by graphing. So that concludes our last lesson in Unit 7, which was on systems.